It's been pleasure coming here. So it's been a week or more than a week, probably 10 days here. And thank you for allowing me to present this topic here. So as I know it's a 20-minute presentation, I was wondering what to give because I was just settling in and looking for topics, what to present, and then so today's topic would be on some of my published work from last year, and then I have more topic, but I think it's pretty preliminary or early stages. So I thought maybe the issues I work on, I could give a broad introduction rather than give a full-fledged working paper, because at the point of sabbatical, I wanted to work throughout my sabbatical, so I still have very preliminary results. So I can present what I have from my recent work here. And let me see if it's working. Okay, so primarily I'm going to talk today for 20 minutes on oil price shocks and U.S. economic activity. As the energy shocks are pretty prominent, and then we also it matters a lot with the now oil supply shocks and gas shocks right now, what's happening in Germany. So I thought maybe with that context I can give some presentation here. So the findings for this presentation is coming from this paper, The Effect of Oil Supply Shocks on U.S. Economic Activity, What Have We Learned? And it is a joint work with Ana Maria Herrera at the University of Kentucky, and this is published work in the Journal of Applied Econometrics. Okay, so if you look at this graph here, this is the oil price, West Texas Intermediate. So that's the benchmark what we use in United States at least. And then so you can see that there's no long-term trend in this graph, and mostly you see fluctuations after 1970. Pre-1970, the oil prices were mostly regulated. So in my research, I focus mostly after 1970, and there's no trend in a sense, but the fluctuations you see are mainly because of some supply shocks or demand shocks or some inventory shocks, what you're seeing here. And when I say supply shocks, these might be some of the exogenous, maybe because of the Iranian revolution in '79, and then Iran-Iraq Gulf War, in 80s. And again, you see a big jump here because of the global demand shocks after 2000, maybe the countries in India or China, they were demanding more oil in early 2000s. And then once we had a financial recession, you see a dip in the oil prices, 134 or, from barrel to $39. So there was a huge drop again. And then we had some shale revolution also happening. So, but the idea of this graph was to show the fluctuations in oil prices are because of in the literature, we say either it's supply shocks or demand shocks or some precautionary or inventory shocks. Okay. So the main research question we ask in this paper is how large is the estimated effect of supply disruptions on real oil price? So if you have a supply disruption, that is global oil production goes down, then what is the effect on the oil price? And if you look at the literature, there has been considerable great work has been done by Jim Hamilton, Luz Killian, but the estimates vary a lot. The estimates are very broad, so you have a range between 0.05% to 4.2%. So there is a broad range in terms of the results, and the peak when there is a supply disruption, then obviously we see oil price going up, and we also see when does a peak occur. It's after 2 months after the shock or 4 months after the shock. So there's also there's difference there, and then so that made us to think into this area. Where do these differences stem from? Why are we seeing these differences? And some of the differences are how we identify the supply shocks or demand shocks. How are we identifying what kind of model we are using it? And then differences in specification, that means lag length, or what kind of priors we use, or estimation method. So mostly in macroeconomic literature, we use structural vector regressive models to estimate the effect. But there has been recent advances using the Bayesian approaches. So we have frequentist approach and also the Bayesian approach to identify the shocks. And so depending on which side you are, sometimes the results vary. So the idea was to look at all these models and see where are these differences. And so if a researcher is trying to work in this area, they can understand the models better. So that was the idea behind the research. Okay, and also look at what is the role of supply shocks in driving the fluctuations in U.S. real GDP. So looking at if you have a supply disruption, what impact has an oil price? In turn, if oil price changes, what impact it has on the U.S. GDP. So the oil market data is all in monthly, and the GDP data is in quarterly data. So we're trying to see also the monthly effect on oil price, but also the quarterly effect on the GDP. Okay. So that's the kind of a research question, what we are looking in the paper. And then, so I'm just giving you the historical context, as many of you probably already know it, but I'll go a little bit faster here probably. 1970s, as I mentioned, we had several exogenous political events were happening, like the Iranian Revolution, Iran-Iraq War, and so those kind of disruption has caused the oil prices to go up, and then especially in the United States, when oil prices went up, they created a strategic petroleum reserve, so basically inventories, so that they can use for the future, and energy efficiency standards for vehicles, national highway speed limit for 55 miles. So these were the things which were policies were created to tackle the oil security. The question here we are asking is, how can we estimate from the data the key parameters that enables us the following questions? So what is the causal effect of oil supply disruptions on the price of oil? And again, what is the causal effect of changes in oil price on US real estate? So these are the two research questions, right? So that's where I'm going. So in aftermath of 1970 shocks, primarily economists and policymakers appear to reach consensus that most of the oil price fluctuations, what we've seen is because of the supply disruptions that are exogenous. That's not within the United States, but something happened outside in OPEC countries, maybe Iran, Iraq, or Libya, something happened there that affected the US economy. So mostly exogenous events causing the fluctuations in oil prices. And consequences, when oil prices go up, then it results in increased inflation, decline in aggregate economic activity, US GDP. So, and we will fall into recession. So that was James Hamilton was a pioneer in this kind of research in early 2000s and 90s. So after we have oil price shocks, we will have recessions. And so that was the line of research. So supply shocks contribute mainly to the fluctuations in oil prices. So that was the literature pre-2003, okay, in the macroeconomics. But we are not in 1970s, and US has moved away from, importing oil to now producing oil, to shale oil, right? So, so again, so some of the questions I'll go. So I'll give the outline, what I've given outline. And I'll talk about the identification problem. Why can't we use a simple regression model, a simple static regression model to estimate, what is the impact of oil production on oil price, or, economic activity on oil price. So I'll go through the identification problem, what we can see. And I'll show I think these are just the outline here. So the identification problem. So this has been a main problem. Earlier, to see the impact of oil price shock effect on the economic activity, one would just run a simple regression model, having a economic activity on the left-hand side and oil price on the right-hand side, and just, run. But I think we have some identification problem if you use a simple static model. So I'm going to show you that with simple math equation here, but I'll not go in detail. So if you have a simple, like a 3 equations, so Q is oil production here, Y is economic activity, you can think about, and P is the prices, okay? And so these are labeled here: world oil production, global economic activity, oil price. And so if our goal is to see what is the impact of oil supply disruption on the oil price, we are interested in this parameter, beta PQ. And if we are interested in what is the impact of global economic activity on the price, this is the other parameter we are interested, right? So obviously we would expect the beta PQ, this red one, should be less than, so, and okay. If supply goes up, then this should be less than 0. And then if aggregate economic activity goes up, then this should be greater than 0. And these would be what we call as the macroeconomic structural shocks. These are uncorrelated to each other, okay? We need to estimate some beta PQ to answer the question posed above. So that's what the question. So there are problems in estimating the beta PQ and beta PY because you can see that there is a reverse causality happening here. We also have an equation in number 1 and number 2 where prices can affect the production, and also the prices can affect the economic activity, right? So in that sense, so here, so what we expected is this one. Oh, sorry, I think I went too fast here. Beta PQ is less than 0, beta PY is greater than 0. That's what we expect. And here we also have this: if prices go up, supply will go up. So that's what's greater than 0. If prices go up, the demand will go less than 0. So, but the idea to show this equation here is that there is a reversal process happening. So X is causing Y, Y is causing X. So how to identify the shock, like, very clearly. So that's the idea here. Okay, and then, without any assumptions, we cannot see the impact of supply on the price or the demand on the price, right? So we have to make some reasonable assumptions, okay, here, and to identify, to get these beta PQ and beta pi. Why is identification important? Because sometimes correlations, we try to convert the correlations into causations if we don't identify the shocks properly. So that's why we need to have a good identification mechanism here. So if I was a microeconomist, that I would do a different way, like, natural experiments, or randomized control trial, those kind of methods mostly microeconomists use, but macroeconomists, it's a little bit difficult because dynamics are crucial. So we are interested in what is the impact of shock in this month, and also for next 12 months or 24 months. We are trying to see this impulse response, how they propagates over next 12 months or 24 months, okay? So we're not looking at one point in time, but also for several months in future, right? So for forecasting purposes also. And expectations play a key role in transmission of shocks, and general equilibrium matters a lot. So how we hold other things constant and see the impact of one variable on other. So also in macroeconomics, we put the lags of the variable to see this dynamics, right? So we have these lags. Once we put the lags, but the problem has not solved still. We still have this problem here, the reverse causality issue here. And what can we do? So the first approach, it's pretty common, what we call Cholesky decomposition or recursive ordering, what we call. So we make some exclusive restrictions or zero restrictions, what we call. So for that, we make some reasonable assumptions saying the oil production does not respond contemporaneously to Y or P. So that means that global oil production does not respond contemporaneously within the same month to aggregate economic activity or the price. So that's one assumption we make. And Y, the economic activity, does not respond to P, but responds to contemporaneously to the Q. So they react in the same month to the Q, but not with the price. So, and then P responds to the Q and Y. So that's kind of a reasonable assumptions we make. So that will allow us now to put the, so now you can see that, I'll show you here. So now, if you make these assumptions, you can see that clearly those parameters go off, right? And then now it's easily to for us to identify the impact of oil supply shock or aggregate demand shock on the oil price. So that has been the VAR literature, vector autoregressive models. This is what the reasonable assumptions they make, and then they estimate the model. And one of the first model, first VAR model, work has been done by Barsky and Killian, or Killian work in 2008, which follows the vector autoregressive model. So, and also making an assumption that from what we have seen in the last slide, the supply curve is a vertical. You know, it doesn't change with the prices basically. So it doesn't respond contemporaneously to the prices. So that's one of the assumptions here. Okay, so just if you recall, supply disruptions, as I said, these are exogenous. So if something happens in Saudi Arabia or Libya, and how does that impact the US economic activity, right? So that's what, so if, I mean, this is an event that happened on Saturday, September 14th, an attack damaged Saudi Aramco oil processing facility. And so they stopped it and stopped the producing the oil. And on each day, you know, basically it has a capacity of 7 million barrels, equivalent to 7% of global crude oil production capacity. So this is kind of disruption what we are talking about. Supply disruption happening outside the United States. How does it impact the US economy? Okay, questions again. So the questions I can put here is, what is the causal effect of 5 million barrel decline in world oil production on the price of oil? And how does that affect the global economic activity? Okay, so we're going to use this this model, what we have just underlined with 3 equations. Okay, but for 1 million barrels. So we are interpreting for 1 million barrel, right? These parameters, what we are using is 1 million, and you can multiply to make it big. So the impact of, if you have a disruption here, what is the impact on the price? If you have the increase in aggregate economic activity, what is the impact on the price? Okay, so that's the, I'm looking at the time, so making sure I'm not going over the time. So in this paper, we use the data from 1973 to 2016, and so, and a monthly data. So any global oil market model has 3 primary variables: crude oil production and world economic activity and the real oil prices. So these are the monthly data here. And we also have a quarterly data, US real gross GDP, basically. Okay, initially, so as I said at the start of this presentation, we are looking at these different models. Why are they giving different results, right? The estimates are wide, broad range. So the first model is a simple model, which I just showed with 3 equations. That's the model 1. And in the model 2 is basically add inventories. So from model 1 to model 2, you just add 1 more variable to these 3 variables. That is, you know, how many inventories the US has it, or, you know, so if you have the data, you add that in the model and see it's more complete in that sense. And initially, this is what we call recursive ordering or Cholesky ordering. That's the model 1, basically. And then model 2 is slightly different, but we added inventories, right? And model 3 is we are making it that assumption that supply curve is not anymore vertical. You know, earlier I showed a graph where supply does not respond to contemporaneously to the changes in the prices. So that's the recent work by Baumeister and Hamilton. They have made that changed where supply curve is not exactly vertical. It can takes, it's not vertical. So let's, I'll keep it short. And then, so that's the model 3. So let's see the results. I'm not showing all the math behind it, but at least the results. So model 1, let's see here. That's the kind of extending the Killian model. Lutz-Killian model was until model 1, which is until the data 2008, but I've extended the data until 2016. And if you see that if world oil production goes up by 1%, this is a shock here. And then these are the months on the x-axis. This is a percentage. And how would that impact the oil prices? So these are the confidence bands here. The black line is the point estimates. So you give a shock in the first month, and how does the oil price respond to the shock? So that's kind of the idea of the second one. So you can see there is a positive response, but it's not statistically significant. But I mean, I think it's barely significant in some months here, but more or less is not significant. That's the idea of the Killian model, saying supply shocks doesn't matter anymore, and we see a very less effect on the oil price. But this is the model 1 which I showed. And if you add the inventories, okay, so this is the model 1 I've just showed you already. But if I add the inventories to the model, a 1% decline in world oil production, and you can see the magnitudes are a little higher here, and you can see the oil prices are up and coming down here. Positive response, statistically significant. And this model 3 is a Bayesian approach. So these two, at least this one is clearly, these two are frequentist approach, and the model 3 is a Bayesian approach. And in that approach, if you decline the oil production by 1%, you can see that you're getting much higher response to the oil price here. Okay, so and there's also an assumption that oil supply curve is not vertical anymore, right? In these two models, oil supply is vertical, and here it's not vertical anymore. So with changing the assumptions slightly, you're getting the much bigger effect on the oil price, right? And this is a monthly data. So once you have the effect on the oil price, but GDP, you might ask the question, the GDP data is in quarterly, right? How would you estimate? Do you have monthly model and then quarterly? So with these 3 models, I can extract the structural oil supply shocks, and then I can run a simple autoregressive model on the GDP where I get these responses here. So if there is a supply shock, a negative supply shock, how would that impact the GDP? So this is again months. This is quarters again here. This is all quarters here, and you can see that the GDP declines in all these 3 graphs. But you can see that the last model gives much higher magnitude, I would say, compare. I mean, it's not statistically significant here, but this model 3 gives you much higher magnitude. Okay, I'm just looking at the time. So I'm going to give you final remarks here with this model, so we can have some discussion at the end. So oil price shocks and U.S. economic activity. The causes, the usual suspects, what we see is supply or demand or precautionary motives. Those are the causes that causes the oil supply, oil prices fluctuations. And once we have what are the consequences? An oil supply disruption that results a 10% increase in the crude oil prices leads to 0.3 to 0.5% reduction in US real GDP, and a year after the shock. So that's like at the peak effect, what we are talking about. And depending on the model assumptions, how many lags they have set, what kind of priors, what kind of methods you have, these results vary. But if you make those assumptions aligned in all the models, more or less the results are very same. Like what I've seen is even with the model 3 here, a model 3, sorry, I have to be slow here. Model 3, I've tried to change their assumption to make a supply curve more vertical based on the priors, what they've chosen, and the results converge to the previous model. So, so the idea of this paper is the key thing is what is the identification mechanism you're using to extract the supply shocks, how many lags you're using, and what kind of priors you're setting in the model. So those are the three main factors that gives you the different kind of results across in the literature. Okay, and so yeah, so that's my presentation about the oil supply shocks and on the U.S. economic. If you have any questions, or we can discuss